now what we're going to do is sort of combine all of the different transformation types, the shifts and the stretches and the compressions, and put them all together in sort of one big function transformation. So our standard form of writing the transformations is going to be this a times f of, and then on the inside, b times bracketed x minus h, and then plus k. And so the reason why we write it like that instead of just simplifying the inside is because it allows us to actually do the transformations ADHK from left to right. There are other orders that you're allowed to do it in, but this is really easy to remember. So if they're written like this, then you should hopefully remember that A on the outside is going to be a vertical stretch, right? So it's on the outside, it affects the Y value, and if A is big, it'll be a stretch. If A is small, it'll be a compression. And if you recall, if A is negative, it's going to sort of flip it upside down. Now, the nice way of sort of keeping track of all that information is we could just say it takes your Y and it turns it into A times Y. It just multiplies all the Y values by A. And then you don't have to think of it as two different actions, a stretch and a reflection. And then we make our way to the right. So step 2 would be looking for whether or not there's a horizontal compression. So that B value, now if you recall, it's on the inside of the function. It's going to do the opposite of what it looks like to X. So if B is big, X is actually going to get smaller. It's going to compress. And if B is large, then X is actually going to get larger. And again, if B is negative, it'll be that reflection. The easiest way to just keep track of this is it takes your x's and it turns them into 1 over bx. So it divides your x's by that b value. And then again, making our way to the right, the next letter we hit is that h. So that's going to be step 3. So that minus h is going to shift to the right by h. So it's the opposite of what you would think, right? Right is the positive direction, but we're subtracting. So we can think of that as just x goes to x plus h. And that plus k on the outside of the function will affect the y values, and it'll go up or down depending if k is positive or negative. So I prefer to, rather than thinking of these things as like compression, stretches, shifts, I just do these little math steps. To me, that makes a bit more sense. Now, I did mention the order is fairly important. This isn't the only order that you have to do it in. The verticals don't affect the horizontals at all, so we can mingle those a little bit. But if it's written like this, A has to come before K and B has to come before H. So the A and the K hopefully make a little bit of sense because that's just order of operations. You do multiplication before addition. The B and the H might not be as intuitive, but remember that what we're basically trying to do is find the X value that gives you your, I'll call it I for input. So that gives you the input of the original F function. And so what we would be doing is solving for the input of this new transformed function, which is your Bx minus H, and setting it equal to whatever input it is that you're looking for in the original function. And what we would do now is actually solve this equation. So the first thing we would do is divide by b, right? And that is step 2 in my list of steps. And then we would add h, which is step 3. So that's why 3 comes after 2. All right, we divide by b and then add h. So that's the order in which we would do that. So that's why we write it that way, that factored way, because that way the numbers that you push away from the h are read left to right. So it's just makes it easier for us to remember. Okay, so now I'm giving you this graph of a function y equals f of x. So it's just this kind of weird looking piecewise graph. And yeah, so we're just going to go through and do all of these transformations on it. So we're going to do A and B. You'll notice B is written a little differently. So for A, what we can do is go through and identify the transformations. So the first thing that we hit here is that minus. So that's going to be our A value. And so that'll be step 1. we have a is, that minus is basically just -1, right? It's -1 times f. And so what that's going to do for us is take all of our y values and multiply them by -1. So all the y's go to -y. Step 2, we make our way inside there. And that is going to be the b. So b is 2. And so that's going to do the exact opposite of what it's doing to the x inside the bracket. So all of our x's are going to get cut in half. And then finally, I'm going to do step 3 here. And that's going to be that -3. Again, that's on the inside of the function. It's affecting x. So what we're going to do with that is move all of our x's to the right by 3. Okay, so I've drawn the axis already. So what I'm going to want to do to get this started is actually just completely redraw the f of x so that I can sort of track it as I do these 3 transformations. So I'm just going to make that happen. All right, so I've got my function drawn. So yeah, I'm just going to one by one apply all of these transformations. So the first one, all my y's turn into -y's. So I just take every point and sort of flip their heights around. So this leftmost point is currently at a height of 0, stays at 0. The next point is at a height of -3, so it's going to come up to +3. The point after that has a height of -3, so it's also going to go up to +3. Notice that my x values don't change at all here, it's just my y's. And then this open dot has a height of 2, so I'm going to move it down to -2, and it's going to stay an open dot. And I'm just going to maybe use a dotted line to connect these because it's not my finished product, and it gets really messy if you draw all the lines. So that's step 1. So now what I'm going to do is move on to step 2. So all my x's get cut in half. You can actually do the calculation on the x values, or you can pretty much eyeball it. I'm just going to do the calculations as I go. So the leftmost point is at x is -2, so cut that in half. Horizontally, the x goes into -1. The second point up on the top left here is currently at x equals -1, so we're going to cut that in half to -0.5. And then x equals 2 gets cut in half to x equals 1. And then 3 is going to get cut in half to but exactly 1.5. It's going to be about where I draw it. It's not going to be perfect. So you should be able to see from this picture that it does look condensed. And this is the nice thing about actually drawing these steps rather than just sort of calculating the values on the side, is that it would be pretty obvious if I make mistakes, because like the step, it wouldn't look like half of the other picture. It would look really different. So they would jump out at you a little more than if you just write a bunch of numbers. Now finally, the last step is that h equals 3 that I've written down. So I'm just going to move all of these to the right by 3. Yeah, just move them over. So this leftmost point is at -1. It's going to go right to +2. -0.5 plus 3 is going to end up at 2.5. Doesn't have to be perfect. 1 plus 3 is going to go over to 4. Oh, my point there looks like it's too far over. Let me fix that. Yeah, I went over to way too far over. I went to 3.5, not 2.5. And I knew that because I looked at the next one. Yeah, so half goes to 2.5, which should be right about here. 1 is going to go right by 3 to 4. All right, so by drawing the picture, I recognize that those 2 points were too close to each other. And then 1.5 should go over to 4.5. So it's just going to all slide to the right. And on this one, I am going to connect all the dots. I don't like that line. I'll try to fix it a bit. There we go. And yeah, that should be my graph here. So this is y equals negative f of 2x minus 3. Yeah, so that should be the next one. And so that would be our finished product. Okay, so moving on to B, what hopefully you'll notice is that this isn't quite written the way that we want it to, so that inside is not factored. We can still work with this, it just does change the order of things, and so you have to think about it a little more instead of just go left to right. So I'm just gonna go ahead and factor it. What we're gonna do is rewrite the inside by factoring out the half. And so when we factor out the half, factoring something out is just like dividing. So if I factor a half from 1, you're basically asking how many times does a half go into 1? Twice. So you can also think of it as 1 divided by a half. And so we should be getting that inside of a half bracket x plus 2 like this. And then now we can label our a, b, h, k according to that standard form. All right, so I'm just gonna go left to right. Again, I've got A is a third. I'll just use the same colors here. Not B. Step 2 will be B is a half. So like that equals. And I am gonna actually just kind of cheat a little bit and do steps 3 and 4 together. They're both shifts, and shifts are pretty easy. You're just kind of sliding the whole picture. So I'm gonna do them at the same time. So remember, we're doing this factored for version. So it's gonna be that h is actually negative 2. And k is plus 1. So I'll do those at the same time. All right, so before I just write out what these things do, again, I'm gonna make my table here. Usually I will give you guys a graph so that you can just draw it on the hopefully with a grid too, if you are expected to draw anything. So I gotta make my scale. So I'm just gonna be mindful of the fact that I know what that B is gonna do. Might as well actually write these out as I go. That B is a half is actually gonna double all my X's. It does the opposite of multiplying by a half. My Y's are gonna get compressed. And then there's just gonna be some shifts. So those aren't gonna do too much. So X is gonna go left by 2, and Y is gonna go up by 1. But what I want to be mindful of is the fact that Y is doubling, X is doubling. So I want to make sure I have enough to actually do that in my scale. So I need to make sure I go at least up to 6 on the right here for that doubling. So I might need to do this a little smaller. There's my 5, and there's 6. And I'll go about as far on the left. I have a little more space. I'll go a couple more. Now, for the y-axis, my y's are cut in thirds. So I'm going to actually exaggerate the y-axis a bit. They don't have to be the same size. But I'm going to do this so I can see that third a little bit better. All right, so what I'll do next is just draw the original graph and then start doing things to it. All right, so like magic, I've got the original graph there. You'll notice that the shape is actually different than the original f of x that I drew, but that's only because I've sort of played around with my scale a little bit, and that will give those stretching compression effects visually, but the points are the same, so it is still the same function. Yeah, let's start with step 1. So my y's are gonna get cut by a third. So y is 0, stays at 0. -3 is going to go up to -1 for both of those 2 points, and the x's stay where they are. 2, so I have to take a third of 2, which will be 2/3. It's not ideal, but I can just kind of eyeball where that is on the graph and just make sure I also use an open dot. So that looks okay. Just a little bit above half. So that should be compressed by a third, so it should just look like a squeezed down version. And next, it's going to double horizontally, so just take all my x's and double them. -2 to -4, -1 to -2, 2 to 4, and why I needed all this width, 3 is going to go across to 6. And again, just jot down kind of a dotted line here. Just to act as a guide for what I'm doing. And then finally, these 2 shifts. So I'm going to slide it left 2, up 1. So left 2, up 1. And then left 2, up 1. That actually goes right on the same point there. Yeah. And left 2, up 1. And left 2, up 1 for the open dot. And then we should be able to draw the lines, and hopefully this works out. All right, it's a little bit hard to see. I might draw over this freehand so I can kind of make it look a little thicker. Oh, that looks terrible, but you get the idea. Hopefully it's supposed to be straight. Mostly I just want that x-axis one to look a little more emphasized. Yeah, this looks real bad. It's okay. Should have just drawn more lines over top. All right, it's not supposed to look furry, but it does. And yeah, so this would be our final output here, the 1/3 f of a half x plus 1, and then plus 1 again. And so what we can do here is actually, check and see that this is consistent with what we've got on the original graph, just to make sure that all the stuff that I'm doing here makes sense. Let's say we just take an arbitrary point on this graph. Let's say I go with, how about x equals -4, which should correspond with this point here. So what I'm going to do is plug it in. X equals -4. So I would have y equals 1/3 f of a half of -4 plus 1, and then plus 1. Let me fix that silly looking 4 there. So what we would do next is simplify that inside. So 1/3. And so we would have a half of -2 is -2, plus 1 is -1, and then plus 1. And then now to evaluate this f of -1, we would use the original function, which would be right here, and f of -1, it says, is -3. According to this graph. So I can plug that in. Oh, no, I've got my f. I don't need to rewrite it. 1/3 of -3. Is that right? Yeah, this looks right. I almost panicked. Plus 1. And so what we can see here is we've got -1 plus 1, which is 0. And that corresponds with the y value of this point that I have. So it moved this point correctly according to what the original function says it should do. So the way that I dealt with this different writing on the inside, it seems to work out. So just a little bit of evidence that what we're doing here is actually what we should be doing. But your final answer is that burgundy colored graph there. So Yeah, that's how you're basically going to be able to handle any transformation that you encounter. Either if it's already factored, just make your way left to right and apply the rules. If it's not factored, factor it. You might get some fractions. It's not the end of the world. Um, you might have to just deal with them, but at least if you do the factoring, you can just make your way left to right. If you're curious about how you can do it without the factoring, ask. But I don't want to teach a second method that's significantly more confusing to people that don't want to know. So that'll wrap this one up.